Welcome back to my YouTube channel. So today I'm up with the next question of top 150 interview questions of LeetCode, and this is the important question in terms of an interview preparation. So let's get started with today's question. Today's question is longest consecutive sequence. So stay with me till the end of the video and let's discuss the code, the optimized version of this problem, and let's get started. So we are given an unsorted array of integers nums. We have to return the length of the longest consecutive elements sequence. So we are given an array nums. We are given some numbers in nums, and we have to find the sequence of elements which is consecutive in nature and has maximum length. So let's get started with the question. So after seeing this question in terms of some mathematical aspect, what is the naive solution that comes to our mind? So you all will say me that let's sort this array, which would turn out to be 1, 2, 3, 4, 100 and 200. And we will simply figure out the maximum consecutive element sequence in this sorted array, and we'll get our answer to be 4, this to be 1, this is also one of the sequence that exists, and this is also one of the sequence that exists. So the maximum length exists over here is 4. So what is the time complexity of this solution? It is n log n, and the space complexity is big O of 1. But there is a condition to this. So after seeing the solution, I'm very hopeful that none of the interviewers will be happy. So he or she will actually demand you to optimize this solution. So let's move towards the optimized version of this solution. And obviously we have to optimize this solution because there is one more reason towards it. Just ponder upon the constraints that we are given. We are given nums of length to be 10 in the constraints of 10 raised to power 5, and the maximum size of nums of I that we can actually use as an input element in our nums is 10 raised to the power 9. So what would happen if we use this naive solution? So our number of operations would have been 10 raised to power 14. That's what the reason is. So that's why we need to optimize this solution further. So before optimizing it, let's just have some mathematical look over this solution. So what it is? Let me draw a number line. Let's just write down all these numbers on some number line. 1, 2, 3, 4. And we have somewhere over here 100, and then we have something like 200. Okay, so this is what we are going to do. So what you can see, we have something like some sequence existing over here, some sequence existing over here, and some sequence existing over here as well. Even before discussing this point also, I have mentioned in the naive solution also that this is also one of the sequence whose length is 4. This is one sequence whose length is 1. This is also one sequence whose length is 1. So what I'm trying to actually figure out is, I'm trying to find out some sort of sequencing. Like I can find out some sequence in a way that I can find the maximum length sequence with all the elements in consecutive order, right? So that's what we are going to do. So how to represent this thing, this number line in our code? That's what the challenge is. So we can solve this challenge by using a data structure known as unordered set or hash set in Java. We can use this data structure set. What we will simply do by using this data structure, although in this case there is one constraint that our space complexity will actually turn out to be big O of n, because we are actually storing all the elements that are present in our nums array in this set. So we are actually using some extra space in it. But believe me, in this case, we are actually improving our time complexity as well. So what we will do, we will simply insert all the elements that are present over here in our set. 100, 1, 200, 3, 4, and let's say 2 also. So I have simply inserted all my elements in the set. So what I will do, so in order to find out such sequence, what we need to actually determine, we need to determine the starting element of this sequence. So what all could be the possible starting elements of a sequence? It could be either 1, it could be either 100, or it could be either 200. That's what the point is. So all these three elements are the possible elements that could be starting of a sequence. So whenever we will find some starting point of a sequence, obviously we'll keep on adding +1 to each and every element, to the element from where we start. So that's for, so after adding +1 to the element from where we start, the starting point of the sequence, we'll keep on adding +1. If we actually have that +1, that x plus 1 in our set, we will say just move forward. And if we don't have, we will simply skip out and move further to iterate over the set to find out about other elements, the whereabouts the other elements. So what we will simply do, so suppose then I am trying to iterate over my set. So the first step that we have to do in this solution is simply insert all the values in the set, in unordered set or maybe in hash set if you are coding in Java. So after inserting all these elements, what we will simply do, we will simply pick up an element from a set, try to find out that whether this element is the starting of some sequence or not. And how we will find out that whether this element is starting of some sequence or not, we will simply subtract some, we'll simply subtract 1 from it and check if this subtraction, if this element, if this resultant exists in a set, then it means that this element can never be the starting sequence, starting element of some sequence, and simply we will jump further. So 2 is not the starting of any sequence. So now let's move further to 4. Is 4 the starting sequence of some element? 4 minus 1, 3? No, it's also not, because there exists a just smaller value for 4 in our set. So 4 can also not be some starting sequence. So let's jump to 3. Let's find out, is 3 a starting element of some sequence? So let's do it by simply subtracting 1. No, because 2 exists in our set. So 3 can also never be a starting element of some sequence. So now let's jump towards 200. So is 200 a possible starting element of a sequence? Yes, it is, because 200 minus 1 is 1999 and 199, and 199 doesn't exist in our set as of now. So 200 can be a possible starting sequence, starting element of a sequence. That's what the point is. So now let's jump and find out whether there are elements just greater than 200 existing in the set. So now let's check for 200 plus 1, 201. Is 201 a part of our set? No, it's not. So 201, so 200 could be a possible starting sequence, but since there doesn't exist the next consecutive element which is greater than 200, so 200 could be one of the possible answers, but it is not the correct answer. So Fair enough. So let's jump further in the set. So check for 1. 1 minus 1 is equal to 0. Is 0 present in our set? No. So, so 1 is one of the possible sequence from where we can start our start the maximum consecutive length sequence. So now let's check for 1 plus 1. Is 2 a part of set? Yes, it is. So what is the maximum length that we obtained till now? It's 2. So now let's check for 2 plus 1, 3. Is 3 part of set? Yes, it is. So our length gets updated to 3. Is 3 plus 1, 4. Part of this set? Yes, it is. So our length gets updated to 4. Now let's check for 4 plus 1. Is it part of 5? 5, is it part of set? The answer is no. So we will simply, so for 1, the possible answer that we got is uh, 4. So we have got a length of 4 when we have 1 as the starting element of a sequence. And whenever we have 200 as the starting element, we have only one length sequence existing for it. Now let's just find out for 100. So is 100 one of the possible element in the starting sequence? Yes, it is, because 100 minus 1, 99 is not the part of our set. So we will simply say that 100 is one of the possible element that we could have. So is 101 part of this set? The answer is no. So we will simply say that 100 could be one of the possible sequence of length 1. So after computing all of these lengths, find out the maximum length, and that is our answer. So, so after discussing whole of these steps, the time complexity of this optimal solution turns out to be big O of n, and the space complexity turns out to be big O of n, because we are actually storing all the elements present in our nums array in some set. So we are using an auxiliary stack space in order to optimize our solution. So now let's jump towards the code for this problem. So what I've done, I've simply inserted all the elements in my set my max length to 0, iterated over my set, find out if the minus 1, if there just exists a smaller element in my set. If it exists, it is not part of my answer. If it doesn't exist, then I will simply check for the elements that are just greater than the given element at that point, and I will simply return my maximum length. Now let's just run this code. It works fine. Let's submit it. So it works well. Let's analyze the time complexity. It is big O of n. Let's analyze the space complexity as well. Okay, it's also big O of n. So I hope guys you have understood this question. If you have understood, please do hit the like and subscribe if you are new to the channel. And if you feel that I've explained it very well, I request you to share this video amongst your friends and peers. So it really helps me a lot, and it also really helps you as well, because it's a win-win situation for both of us, right? So help. So that's all about today, and keep watching my videos. Thank you so much.